So today I want to tell you a story. It's the story of how product manager, me, went from feeling completely lost in AI meetings to actually building a pretty impressive image classifier. If you're a PM who really wants to finally crack open that black box and get a feel for how the magic actually happens, well, this one's for you. Does this sound familiar at all? You're in the room, you're nodding along while the engineers are talking about training epochs and loss functions, and you're just trying desperately to connect it all back to the customer. I've been there. I decided the only way to really bridge that gap was to get my hands dirty and build a model myself from the ground up. Okay, so before we get into the whole building journey, we need to get on the same page with just a few key ideas. And trust me on this, once you get these few little building blocks, everything else that follows, all the failures, all the breakthroughs, it's all going to click into place. First up, the most basic piece of the puzzle, a single neuron. The absolute easiest way to think about a neuron is to picture it as a tiny little analyst. It just takes in a bunch of information, decides how important each piece is, and then makes one simple call. By itself, a single neuron isn't all that smart, but it's where everything begins. And here's what that looks like. See, on the left, you've got all these different inputs, and each one has a different weight or importance. They all feed into that one neuron in the middle, and it spits out a single answer on the right. That's really it. So, if one neuron is a tiny analyst, what happens when you get a whole team of them and you organize them, kind of like an org chart? Well, that's when you get a neural network. It's just a whole bunch of these simple decision makers all stacked up in layers working together. And here's how it all builds up. Your data comes in through the input layer. You can think of that as the mailroom. Then it gets passed through all these hidden layers. Those are like the specialized departments where all the real analysis happens. And then finally, it gets to the output layer. Let's call that the CEO's office, which makes the final decision. Now, for something like images, a regular neural network isn't quite enough. We need a specialist. That's where the convolutional neural network, or CNN, comes in. It's specifically designed to understand how all the pixels in an image are arranged. I like to think of it as a feature-finding assembly line. First, the convolution step detects things like edges and textures. Then, max pooling kind of summarizes the most important stuff it found. The flatten step just gets it all organized into a nice list. And then, the dense layers make the final call. This is such a great way to see that first step in action. Each one of these little squares at the top is called a filter, and you can think of it like a magnifying glass that's trained to find just one specific thing, maybe a vertical line or a certain kind of blur. When you slide those filters over the original image, they create what you see below, these feature maps that highlight different aspects of the picture. All right, so now that we're all speaking the same language, let's get to the main event. My mission, which I chose to accept, was to teach a machine to tell the difference between images of things like mountains and glaciers. And this whole journey really unfolded in 3 acts. So we'll start with Act 1, a really simple minimum viable product, or MVP, that got us to a pretty respectable 83% accuracy. Then, in Act 2, we'll see how we got a bit smarter and pushed that up to 88%. And finally, Act 3, the grand finale, where we stood on the shoulders of giants to get a massive breakthrough, hitting almost 93%. So, Act 1. You got to start somewhere, right? For me, that was a super simple 2-block CNN that I built completely from scratch. Look, the goal here wasn't perfection. It was just to prove that the concept was even possible and to get a number on the board. And the result? 83% accuracy. You know, for a first attempt, this felt like a huge win. We had a model and it was actually working. But a big picture accuracy score like this only tells you if you're winning. It doesn't tell you where you're winning. For that, we had to dig a little deeper. And this, my friends, is a confusion matrix. It is a product manager's absolute best friend for diagnosing what's going on. That nice, clean diagonal line shows all the predictions we got right. Everything off the diagonal is an error. And this one immediately put a giant spotlight on our main problem. The model was constantly getting glaciers and mountains mixed up. So, for Act 2, the goal was to get smarter. I built a deeper, more complex model and used some clever tricks called regularization techniques. You can just think of these as ways to force the model to learn better instead of just memorizing the pictures I showed it. For example, I used a technique called dropout. It sounds weird, but it randomly turns off some of the neurons during training. This forces the other neurons to work harder and learn more reliable patterns. And what was the result? We jumped up to 88% accuracy. And even more importantly, if you look at the new confusion matrix, you can see we were making real progress on that core glacier mountain problem. That smarter training was definitely paying off.
Okay, now for Act 3. 88% was good. It was really good. But building everything from scratch, it started to feel like I was reinventing the wheel. So I decided to try something called transfer learning, basically using powerful models that have already been trained by top research labs. And this is where we hit a really surprising failure.
I started with a model called ResNet 50. It's this well-known, super complex powerhouse from a few years back. I figured this has to work. But just look at that chart on the left. It failed. I mean, it failed spectacularly. The training was a complete mess. So then I tried a more modern, more efficient model called EfficientNet B0. And look at the chart on the right. It trained like a dream. This was such a powerful lesson. More complex is not always better. And that modern champion, EfficientNet B0, it delivered our best performance by far, a phenomenal 92.94% accuracy. We had our winner. But as a PM, a high score isn't enough. It's not the whole story. I needed to understand why it was working so well. We had to peek inside that black box. And to do that, I used a tool called GradCam. The best way to describe it is, it's like giving your model a highlighter. It creates a heat map over an image to show you exactly which pixels it was looking at to make its decision. This isn't just a cool-looking visual, it's an absolutely critical tool for debugging your model and for building trust in it. Here's the perfect example of its power. The model saw this image of the sea with a boat, but it predicted buildings, which seems totally bizarre, right? Until you see the heat map. The model completely ignored the boat and the water, and it focused 100% on those architectural structures way in the background. It wasn't a random error, it was actually a logical mistake based on what it saw. So after this whole journey, from that simple little MVP all the way up to a state-of-the-art champion model, what are the key lessons you can take away for your next AI product? Okay, first thing, start with a simple baseline. Always get a feel for the problem before you go crazy. Sometimes good enough is a much better business answer than chasing 99% accuracy. Second, don't just assume that a more complex model is a better one. That ResNet 50 failure is a great cautionary tale. The modern, efficient workhorse can absolutely beat the old, complicated resource. And third, demand interpretability. Ask your engineers for the confusion matrix. Ask for the GradCams. These are the tools that let you understand why your model is doing what it's doing, and they are essential for building trust with everyone involved. So that was my journey into the world of deep learning. But hey, every product manager's path is different. I'm really curious, what's your experience been? How do you work to bridge that gap between the product vision and the engineering reality when it comes to AI? I genuinely love to hear what's worked for you.